guys, let's look at force vectors at a point, and this is a way to solve something if you have two forces kind of pulling against each other, like this one here. They say two ropes attached to a point and are pulled as shown, give the resultant force. In other words, it's like a tug of war. One's pulling at 30 degrees for a certain length, and one's pulling at 45 degrees for a certain length. What is going to be the end result of that? And let's figure this out. Here is a simplified way to do this, so go ahead and pause it if you want to copy this down. To solve this, first, you're going to redraw these as right triangles, which you can see how that's going to be done. Second thing is you're going to find R and U for both of those. All right, we've done that before. Third thing is we're going to add those R's and U's. Then we're going to take that added R and U and we're going to convert that to polar form. All right, so you can pause it if you want to and write those steps down. Very handy to have those. Make sure you copy those down so you can use them. Okay. All right, let's give it a whirl. So here is our first triangle. It doesn't have to be anywhere close to being accurate. It just has to kind of represent what it is. So 30 degrees here. This is going to be our R. There's our U, and that's a 40. So let's go ahead and take care of that first. All right, let's go to, There's my calculator. So I have a 40. And we're going to, of course, go for R first. We know that's going to be a cosine. We've done that a million times. All right. Okay. So there we go. And that's going to be, you know what? I'm sorry. That should be 30. My bad. 30 degrees is what we're looking at. So 30 degrees, and then a cosine is that. Okay. You multiply that by 40. There we go. And that's going to be 34.64. Okay. So this will be 34.64, and we'll go ahead and just stick the R on there as well. The U, if you recall the 30, 60, 90 triangle, that's going to be exactly half. The sine of 30 will be half. We'll just prove it in here. And there we go, 0.5. And of course, 0.5 of 40 will give us a value of 20 for the U. So right here we have 34.64 R plus 20 U. And of course, on a number line, going to the right will be positive, going up will be positive, just like the X and Y axis, okay? Let's try this one. We have the R here and the U here. The length is 70 here. This is going to be a 45-degree angle. So again, we have adjacent over hypotenuse. That is going to be our first, our method here. So we'll do cosine again. 45 degrees cosine is 0.707. We multiply that by 70. And we get 49 point, we'll call it 49.5. So there's 49.5, we'll call it R. Since this is 45, and this must also be 45 degrees, so both of these will be the same. So sine and cosine of 45 are both 49.5. You can check it on your calculator. There we go. Okay, so this one we have, since this is pointing, in other words, if this is an x-axis and a y-axis, this is going to be a negative x. Or a negative R. This will be a positive R, U. All right, so now we have minus 49.5 R. Then we have plus 49.5 U. If we add those together, we get a 69.5 as a U. And let's go ahead and just do negative, let me get this out of here. 34.64 minus 40, didn't clear that all out, I guess. Okay, 34.64 minus 49.5 will give us negative 14.86. So that'll be negative 14.86 R plus 69.5 U. Okay, now look at the last step. We redrew those, we found R and U, we added, now we convert to polar, okay? So the way we do this is to just treat this as an X and a Y. So let me actually draw just a very rough, really easy version of this, okay? I'll get it over here so we can get it a little bit more visible. Okay, so here's our basic, X and Y axis. Negative 14.86 is my R, so boop, there's a point here, okay? 14.86 R, okay, and then 69.5 u all the way up here. We don't even care. It doesn't have to be accurate, okay? The question is, what is this going to be right here? And there's our fake right triangle. And what is the length of this line, and what is the angle? We don't know, okay? We know this is 14.86. We know this is 69.5, okay? Well, we have an angle, and that angle we don't know. Well, let's see. I got an angle. Well, there's the opposite right there. There's the adjacent right there. And of course, if you remember, opposite over adjacent is defined as tangent, right? Okay, so we have basically the inverse tangent of finding an angle. We'll take 69.5, the opposite, divided by 14.86, and then use the inverse function to find that. So 69.5 divided by 14.86 is that. All right, this is where we'll use the trigonometry and the inverse. The second, it might be on your calculator button, tangent, boom, there it is. 77.9, we'll call it. All right, well, which means this is 77.9 degrees. That's the angle right there. All right, but again, you're asking the captain to come find you, and you're trying to figure out what angle he's going to find you. Okay, so you need to tell him, I'm starting here, and okay, you go all the way to there. And he goes, okay, I know this part of the 180 degrees, if I were to go all the way from here to here, that part is 77.9. So the question is, how many degrees does he turn his ship and point it out there? Well, the answer is going to be 180 degrees minus 77.9. That'll be, equals 102.1 degrees. So in other words, this is our 90 degrees up to here, over until we get to 102. So whatever the second part, first part is, we know this is 102.1 degrees, okay? The only thing left to find out is the length. In other words, you tell the captain how far out do you have to sail at this 102 degrees. And the answer is, we can either use the Pythagorean Theorem, this squared plus this squared is that squared, or we can just go, okay, we can find out the length of this by going, I have 77.9 degrees, and we can take this angle, let's say, whatever you want, adjacent over hypotenuse. You could do opposite over hypotenuse, doesn't matter at all. Let's just do adjacent over hypotenuse. So here's the angle, here's the adjacent, here's the hypotenuse, right? So adjacent over hypotenuse is cosine, right? So cosine of 77.9 degrees equals adjacent, 14.86, over hypotenuse, okay? What's the cosine of 77.9? I don't have the slightest idea. That's why I have a calculator right here. So 77.9, and then we're going to find the cosine. Oops, I don't want the inverse, I want the normal, okay? 0.21, we'll call it, okay? So, don't even write this anymore. I write 0.21, okay? So I'm going to go 0.21 times h equals 14.86, okay? Which means we divide each side by 0.21. So what's 14.86 divided by 0.21? Well, I have no idea. 14.86 divided by 0.21 equals, equals 70.8, we'll call it, all right? So in other words, the length of this side, you tell the captain to sail 70.8 miles out there. So that's what you write right there, 70.8. Boom, there we go. So we have just found, the pulling, I guess we're adding those both together, and what will happen is you'll be, pulled in this direction that way. So there we go. Okay. All right, let's try another type. Look at this thing. This is kind of weird looking. What's different about this one? Yeah, the difference is, like, if this is going at an angle this way, and this rope is not going at an angle like last time, it's just going completely to the right. Okay, now if you had to, let's look at the steps here. We're going to solve this, okay? Redraw it, which we'll do in a second here. Find R and U for both. Add and convert to polar. Boom, okay? Now we can do the right one. The left one, it looks kind of weird. If it's just going to the right, that's an R, but what's the U? If it's only going straight to the right. We'll have to see that one, okay? Well, here's what it is, okay? The one on the right we can draw as a triangle. We know how to do that, right? Look at that one on the right. That's going to be 16 there, 30-degree angle. We'll find the R and find the U, correct? Look at the one on the left. That's the one where you're going all the way to the right, just 10. and not going up at all. So since we're not going up at all, we will just call this 0u. All right. And this one, we're going to have to find out what this b is. We'll call that, make that an r. And this is going to be the u. Okay. So, well, again, same thing. We're going to find the cosine of 30 and take a look at that. All right. So we'll have 30 and then the cosine. And some of these 30, 60, 90s, you're going to find you're getting these down where you know them. Okay. So there's your cosine of 30 right there. All right. And that, of course, is what we multiply by 16 to find out what the length of the r is, and that is 13 point, we'll call it, I don't know, we'll call it 13.9 just to make it simple. Okay, so this will be 13.9r. All right, same thing, we're going to use sine this time to find the u. The sine of 30, of course, you might remember what the sine of 30 is by having done it several times, and that is what it is right there. And of course, 0.5 times 16 will make it to where this is an 8u. Okay. So we're going to add these together now. Now that we have 13.9r plus 8u, those go together. Of course, that is 8u. This will be 23.9, oops, I did 239. 23.9r and plus 8u, that is what we're going to do. Okay, don't forget your next step, which two, we're going to add those together and convert to polar. Now look, again, look at the last one we did. We added those together, and we actually drew what it was going to look like. Okay, we drew the negative 14.86 right here, and we drew the positive 69.5, which means we will draw the exact kind of same thing. So we're going to find 23.9. I'll just use a different color here. All right, let's say it looks like this. 23.9. Oh, well, here's our coordinate plane. 23.9 over, and then 8 up. So. Okay, there's our, I don't know what this is, I have no idea. That length, don't know. All I know is that this is 8 here, and this is 23.9. All right, now I'm trying to find this angle, of course, that's what we want to find a polar coordinate, and we need to find the length of that side. Well, you can look at this angle and go, okay, again, I know what the opposite is, I know what the adjacent is, by definition, that's tangent, okay? So we're going to go, the tangent of something gives us 8 over 23.9. What that is, no idea. So 8 divided by 23.9 is that. All right, what kind of a number gives us that? That's going to be the inverse because we're looking for the angle, not the length. And boom, 18.5 degrees. Okay, so there is our angle right there. So we can actually write this if you want to over here on the little polar coordinate, 18.5 degrees. All right. The only question is now, how far out, Captain, do you need to sail 18.5 degrees to come find us right there? And you can use Pythagorean Theorem if you want to. It doesn't matter. Anything you want. So whatever. Or you can just go, I have an angle here of 18.5 degrees. I could go the adjacent over the hypotenuse. I mean, anything. Let's just try the adjacent over the hypotenuse. Okay, so we have this as 18.5 degrees, all right? So we say adjacent over hypotenuse is cosine, right? So we have cosine of 18.5 degrees equals adjacent, 23.9, over the hypotenuse. Don't know what it is. So 18.5 degrees. And let's see here, the cosine is that, okay, we'll call it 0.95. So that's gone, 0.95 times h equals 23.9. And of course we divide each side by by 0.95. Clear that out. I'll go 23.9 divided by 0.95, and this is approximate, and my answer is 25 we'll call it 25.2. So my hypotenuse is 25.2. Yours might be slightly different from the books based on how many decimals you carry it to and so on. Don't worry about it. If it's pretty close, just go to the next problem you got. Okay, so if that is 25.2, that means my answer is 25.2, and then 18.5 degrees is my resulting force. So, okay. All right. Give it a whirl. Try the practice problem and see what you get. Okay, remember your first step is to redraw these as triangles and do these really fast. Don't waste a lot of time making them look nice. You don't need to. Okay, here's your 58 degrees. Here's R. Of course, that's going to be some kind of a negative R, right? And I'll put negative, something R. And then there's your U. That'll be okay. And we don't, oh, yes we do. Sorry, no, that's a 40. And this is a 30 here. And this is a 22-degree angle. And we don't know this R, and we don't know this U. Okay, well, let's just go to the left one first, okay? So again, we got a 40 here, 58 degrees. We know the routine now. 58 degrees, we're gonna find the cosine, all right? Cosine, bam. We're gonna multiply that by 40. So times 40 equals 21.2, I'll call it, okay? So this negative 21.2, all right? This one, the U, is going to be sine of 58, right? So sine 58, then multiply that by 40, and that's going to give me 33.9, we'll call it. Okay, so there's my first part, 33.9, and I got negative 21.2 R. Okay, let's go with this one. So again, we need the cosine of 22 to find this one. So 22 degrees, cosine is that. And we're multiplying that by 30, so times 30 is 27.8. So there's my R, 27.8. Okay, my U, I'm going to go sine of 22 degrees. Oops, not 222. Okay, there we go. And we're going to, again, multiply by 30. And we're going to give it 11.2, we'll call it. All right? And again, if you're building a building, of course, you want to be super accurate. If you're just doing this stuff, just go as quick as you can. Okay, so let's add first the R's. I got 27.8 plus negative 21.2. That's going to give me 6.6 as an R. All right, now let's go ahead and add 11.2 for the U and 33.9 for the U. That's going to give me, let's see here, 45.1 U. Okay, that is my R and U. All right, now don't forget your idea is to draw this out and convert this into polar, okay? Again, look at the back steps here. Redraw, find R and U, add them, convert to polar. Our only thing left to do now is convert this to polar. So we need to draw a little picture. Basic, very simple picture. Don't make this complicated. And let's just draw an imaginary line. There's our point, okay? Oops. Okay, we'll just go here. 6.6 is over to the right because it's positive. 45.1 is here. That's not even close to being accurate. Look at that. Is that thing like, 8 times as big or 7 times as big as that? No way, but we don't care. Okay, what angle is this? What's the hypotenuse? Again, I say, don't know. That's why I have trigonometry to do this stuff. Okay. All right, let's find the angle first. And again, don't forget, we've got an opposite and we have an adjacent, right? That's called tangent. Opposite over adjacent is tangent. 45 over 6.6. So I'm going to plop it in there. 45.1 divided by 6.6 equals, boom, okay? Inverse tangent, not tangent. We're going to do the inverse. There we go. That'll be 81.7 degrees. So there we go. We know our answer is going to be 81.7 degrees. That's where the captain, now he's pointing his ship in that direction. The only question is how to find me here on this little island with a couple of palm trees here. And a Starbucks right there. Okay. There's the coffee. It's very hot in there. Okay. Where am I? What am I doing? Oh, sorry. Okay, yeah. Coffee. No, Starbucks. Algebra. Yeah. All right. Yeah. Okay. Okay. How far is that thing? I don't know. Let's figure it out. We can use Pythagorean Theorem if you want to. You know what? Let's just do this. What the heck? Okay. 6.6 squared is 43.56. I'll remember that. Okay. 45.1 squared is that. Well, plus 43.56 is that. Take the square root. 45.6 we'll call it. Okay. So let's just say we did it that way. We'll try it and see what we get from this other way. Okay, the other way to find this thing is we can go Okay, I got 81.7 degrees. I don't know, let's try this one. I mean, from this angle, that's the opposite over the hypotenuse, right? Opposite over hypotenuse is sine, right? So we could say the sine of 81.7 degrees is 45.1 over h for hypotenuse, right? So let's try it. What the heck is sine of 81.7? 81.7 and let's see, sine is boink. There we go. Okay, well that's what we're going to divide 45.1 by when we get the answer, right? Okay, in other words, we say the answer is 0.99. Okay, well let's see. Let's take 45.1 divided by 0.99. Noink. Oops, didn't work. There we go. There. 45.6, right? Okay, well, we just said it was 45.6 just by doing the Pythagorean Theorem. So anyway, okay, good enough. Captain, sail out 45 miles, 45.6 miles, and get yourself a nice cup of coffee as well. Okay, all right, that's enough for those. See you guys next time.